Okay, so this is number 16. Number 16 follows the format that looks like this. Notice that the x term is squared. That's kind of what we're used to, y equals x squared. So this is going to be vertically oriented. It's either going to be vertically oriented upward or downward. Depends on whether p is positive or negative. P in this case is up or down. Tells me up or down. A positive p would open upward and negative p would open downward. And remember that HK tells me where the vertex is, just like in the old vertex form. So in this case, HK is going to be negative 1/2. Negative because this is positive and this is minus. So it's the opposite of whatever this is. And then the opposite of whatever this is, 1. So that's where my vertex is. My vertex is going to be at negative 1/2, 1. Now I got to find out what P is. Well, there's your 4P. 4P has got to equal 4, so 4P equals 4, and then P has to be 1, doesn't it? That's positive. It opens upward. So my focus is going to be 1 unit up above that. So here I've drawn in what let's make this 1, that 1. This will be 1, that's 2, and this is negative 1 on the y-axis. So this would be negative 1/2, 1 would be our vertex. And now it tells me that P is 1, so I'm going to go up 1 unit from there to get my focus. So it's going to look something like this. So now the next question is, where's the directrix? Well, the directrix is in the opposite direction from the vertex as the focus. Because remember, all the points on the parabola are the same distance from the focus as they are from the directrix. The directrix in this case is going to be the x-axis. So this is my directrix, which is y equals 0. And I think I've done everything. I've said what the equation of the directrix is, I said where the vertex is, and I've made my sketch. Okay, this is number 20, and in this particular problem, I've got some algebra to do before I can graph it or identify anything. So the first thing I want to do is identify which equation this is going to look like. Well, it's y squared. So the y squared are the equations that have to do with the horizontal orientation. And specifically, this is going to have a modifier for my y, which means this is going to have a k. It might have an x in it. I don't know yet. It might have a modifier left and right as well as up and down. So before I do that, I have to complete the square, and we're kind of accustomed to completing the square. So what I want to do to complete the square is first I'm gonna want it to look like this when I'm done. I want it to look like y minus k squared equals 4p times x minus h. So this has got to be completed. In that part, it would be better if it were on the other side. So I'm going to say y squared minus 4y equals 4x. It's already kind of looking like that. I want this to be a perfect square, so I'm going to use my completing the square rule. So I'm going to cut that in half, and that negative 4 is going to become negative 2. But now this doesn't equal that. So to make this equal that, I have to add a 4 in here. But I can't add a 4 to this side without also adding a 4 to that side. And so now I think they look pretty close to what I wanted to. It would probably be easier if I factor that 4 out. And I get x plus 1. So now I know where the vertex is. I also know what p is because it's too easy to calculate. Isn't this clearly going to be 1? P is clearly going to be 1. Okay, now my HK is going to be for my vertex. It's at negative 1, 2. And I know P is equal to 1. So now I'm going to erase this equation because it's in my way. And I'm going to turn these lights on. So now I have my graph paper all set up here. I want to graph this, and keeping in mind that the y is squared this time, so that means it's horizontally oriented, and it's a positive p, so it's going to open to the right. So, and my vertex is at negative 1, 2, so I probably don't need so much of the bottom part of my graph. I need more of the top part of my graph. And it looks like a one-to-one will work, so I'm just going to call that 2 and 2, and that 4, and that -2, and that -2, and that should give me enough information. My vertex is at -1, 2, and I know my focus has to be 1 unit away from that. It's going to be right here on the y-axis. So my vertex is at, not my vertex, my focus is at 0, 2. And my directrix is 1 unit the other direction. So basically this guy's going to open up this way. Okay, I know that. And I know my directrix has to go right here, the same distance away. So that's at x equals -2. There's my directrix equation. And there's my whole sketch, and I'm pretty much done with that. Okay, well, last example, number 22. Number 22 says x squared minus 2x plus 8y plus 9 equals 0. The problem with this one is it's not at all in the form we're expecting it to be. But it does say x squared, so that tells me that it's going to be vertically oriented, either opening up or opening down. And so the equation I want to compare that with is x minus 8 squared equals 4p times y minus k. Now I want this equation to look like that. Now I got a long ways to go. I've got no parentheses here. I do know I'm going to have a modifier for the x, which is going to mean my vertex isn't at 0, 0. It's either going to be to the left or the right of that. So these terms are actually in the way. I'm going to move them over by subtracting them. So we get x squared minus 2x, leave a gap, equals -8y minus 9. I need to complete this square, so I'm going to cut that b in half, and that makes it -1, and I'm going to square it and add it to both sides. Now that's actually a good thing. I didn't like the fact that that was a 9. Now that I'm adding a 1, it's not going to be 9. It's going to be -8y minus 8. Common factor is -8. And that would leave me with y plus 1. So now I know where my vertex is. My vertex is at 1, -1. And I also know that if -8 is equal to 4p, then p must be -2. This one opens down. That's what that -p is going to indicate to me. So now let me turn on some graph paper here. So it's going to open down, so I'm going to make most of my graph the opposite side. And it says it's at 1, -1, so let's make that 2, and that's -2, and that's -2, and this is 2 up here at the top of my graph. And my vertex is at 1, -1, which is right there. And now my focus is going to be 2 points below that. So 1, 2, it's going to be down there. So my graph is going to really take off going that way. Okay? And my directrix has to be 2 points the other side. So it's going to be right up here at y equals 1. Here's my directrix, y equals 1. I didn't write the coordinates of the focus, so let me do that now. The focus is at 1, -3. You can tell that because I'm going to take that y number, and because this is vertically oriented, I'm going to subtract 2 from it, and I get -3. And so I think I'm done. Got my sketch. And you notice I'm not taking a lot of time to draw the parabola itself. All I really want to know is where the focus, the vertex, and the directrix is, and then indicate which direction it's opening. If I wanted to plot some points, I could, but I don't really see the point in doing that.